Okay, so now we're going to go over number 6 through 10. It says here, due for a hit. A very good professional baseball player gets a hit 35% of the time over an entire season. After the player failed to hit safely in 6 straight at bats, the TV commentator said he is due for a hit by the law of averages. Is this right? Why? The answer to that is no. There is no law of averages. In the short run, anything can happen, but in the long run, he's going to hit the baseball about 35% of the time. He's going to get hits 35% of the time. But in the short run, anything can happen. So again, the answer to that is no. There is no law of averages. In the next one, it's talking about winning if they get a 4-digit number each day. They pick a 4-digit number, and if you have that 4-digit number, you win money. So in this one, it says the winning number might be, for example, 280 or 2,873 or 9999. Those are random numbers from 000 to 999. So their probabilities of being selected are actually the same. People think that because these are repeating in a row, maybe there's a different probability there. That's a common misconception because this is just as likely as this one. Okay, those are just as likely events. Okay, if you ask many people whether these were more likely to be randomly chosen. Okay, wait, what does it say here? If you ask many people whether these are more likely to be randomly chosen winning numbers, most would favor one of them. Use the information in the selection and say which one. So again, I think most people would think this is more common than this one right here, but in reality, these are both equally common. Numbers 0000 through 9999 all have equal probabilities. So getting the number 0000 is just as likely as getting this one. Moving on to number 8. We're talking about free throws with a basketball player. So in this one, when we talk about it, it says that this basketball player is really good. They make their free throws 75% of the time. Explain how you would divide this so that that way you could actually simulate. If I were using a deck of cards, I would choose 4 different suits. Okay, so there are 4 different suits, and so those 4, I would make 3 of them where he or she made it, right? Making it 3 out of 4, which is 75% chance, and then 1 out of 4 would be that they did not make it. If I was talking about the table of random digits, I probably would do, again, I'd select 4 numbers. So I'm going to use 1 through 4 in this case. 1 would be a not make it, and then 2, 3, 4, 3 numbers would be assigned to this one for making it. If I were using a calculator, I would probably either use the same one, or I could use like a 0 and then a 1, 2, 3. Somehow you would break it so that you had 3 numbers representing the make it and 1 number representing the not make it. Another way to do it is I could have instead, and we're going to be doing this in a little bit, I could have done 0, 0 through 74 would be a make it. Okay. And then 75 through 99 would be a miss. Okay, this is 25 numbers. This is 75 numbers. Remember 0, 0, and then to 74, you would go 1 less because that's 75 numbers. And then this would be the other 25% or 25 numbers. Okay, in number 9, determine whether each of the following simulation designs is valid and justify your answer. It says here, according to a poll, 75% of adults regularly recycle. To simulate, you're going to choose 100 adults. You're going to roll a 4-sided die, and if you roll a 1, 2, or 3, it means that they do recycle. That is a 75% chance, because here's your 25%, rolling a 4 means that they don't. This right here is valid. So the answer is yes, this is valid. It's a 75% and 25% split. But in the next one, it says an archer hits the center of a target 60% of the time. To simulate, you're going to have her shoot 10 times using a coin instead. That is not valid because flipping a coin is a 50% chance, not a 60% chance. So the answer there is no. This is not a 60% chance. You would not toss a coin to simulate this because it's a 60% chance, not a 50% chance. Okay, in the next one, it says the Transportation Security Administration, that's TSA, is responsible for airport safety. On some flights, TSA officers randomly select passengers for extra security measures. On one such flight, it had 76 passengers, 12 were in first class and 64 were in coach. Some passengers were surprised when none of the 10 passengers were chosen for screening in first class. What can we do to simulate this? So we're going to state the probability of interest. Well, in this one, I put here, what is the probability that out of 76 passengers on the plane, the 12 first class passengers were not selected for extra security while 10 coach passengers were selected? What are the chances that those 12 first class passengers were not selected, but 10 of the 64 coach passengers were searched? Okay, so that's how we set it up. In B, it says, how would you use random digits to imitate one repetition of this thing? Okay, so I left this so that we could do it together. So in B, the way that I would assign the probability is that if they're selecting 10 out of 76, if they're selecting 10 out of 76 total passengers, I need to figure out the probability of being selected overall. So the probability of being selected is 10 out of 76, okay? Which 10 divided by 76 gives us about a 13% chance of being selected. So we have about a 13% chance of being selected for a random search. And then it says here, what variable would you measure? So if I have a 13% chance of being searched and I have total of 76, I'm going to choose, I'm only going to simulate this once. I'm going to choose 10 customers, okay, and see how many of them were in first class. Okay, so in this one, the probability of being first class, so the first class passengers, there are 12 out of the 76, meaning about 16% are first class. 16% are first class. Okay. Okay, what I'm going to do is I'm actually going to take this 16% and I'm going to break that up to simulate one trial where I have 10 different passengers that are selected and see how many of them should be first class. So I have 16% of my plane being first class. Okay, I'm going to break up the numbers this way. I'm going to break them up into 0, 0, 0 to 15. That's 16 numbers. And then those are going to be my first class. And the 16 through 99 are going to be my coach passengers. We're going to use one line here to do one repetition. So in C, we're going to actually go through and we're going to simulate one trial, which means 10 passengers selected. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 passengers. Let's see if in our simulation we get any that are in first class, 0, 0 through 15. We're going to simulate this. Okay, so my first number that I get right here is, if I'm using this table, 71. My next one is 48. My next one is 70. Then I have 99, 84. Then I have 29. I have 07. I have 71. 71. I have 48. And my last person selected is number 63. So in this simulation, we actually only had one passenger that was first class. We had one that was first class if we were doing this randomly. It's actually, to me, if I'm only getting one from first class, it's not going to seem too rare to have actually had none that were from first class. In our simulation, we only had one. Now, if I had like 5 of them, then I'd be like, I think it's a little weird that none got sampled, but having just one is not that abnormal. I want you to know that when we run simulations, we don't usually just simulate one trial. We'd simulate many of them to figure out what the probability is. But just looking at my one sample, I'm not too thrown off by this. And that's all for homework tonight for that one. That was your first simulation. You will have another